Namaste, I am Rohan Vindakar, and in this video we will deal with omitted variable bias. Prior to the prior to the mathematical derivation of the omitted variable bias, let's discuss about the problems or let's discuss about the meaning of the omitted variable bias. Omitted variable bias occurs when we omit a variable that is relevant to our model, or mm, let's say z as the omitted variable, and covariance between x and z. X means our independent variables and z is our omitted variable is not equal to 0. Then z creates problem, and this is the primary problem of the variable that is omitted from our model. But if covariance between x and z equals to 0, then z is not a problem. It means that if we omit z, then also our model or our coefficients are unbiased. So now let's proof. For proof, let's consider our regression model as y equals to alpha plus beta x plus e. This is the model we are taking, but our original model is alpha plus beta x plus delta z plus e. This is the model to be considered, but we did 1. It means that we left z from our model in 1. So now, as we know that beta hat of OLS equals to summation xy divided by summation x square, and if I open it, then it will be summation xy minus summation, it will be summation xy and summation x summation y divided by n whole divided by summation x square minus summation x whole square divided by n. So now this is the basic OLS, and this is the formula that we use to derive the beta of the OLS, and this formula works in case of equation 1. This is the case of equation 1. But we know that the true model is equation 2. That is, we have missed z or the delta z from our model. So let's check it. Beta hat OLS equals to, so now I will erase it and let's have a look over it. Beta hat equals to summation xy minus summation x summation y divided by n, and let's call it whole as something as v. I will call this whole as v because this is not affected by the z, equals to and I will simply plug in the value of y from equation 2, alpha plus beta x plus gamma z uh, plus e and minus summation x summation it's alpha plus beta x plus gamma z plus e divided by its v equals to, and I will open it. Prior to opening, we know that alpha x is alpha plus beta x plus e. This part is y plus z minus summation x summation alpha plus beta x plus e plus delta z, and its whole divided by its v for our case, and its summation x, it is y from our case y plus delta z minus summation x summation it's y plus delta z whole divided by v, and this value is y from equation 1, and you can recall it from above, equals to summation x y plus delta will come out, it's as coefficient, summation x z minus, and it's summation x summation y minus its delta will come out, summation x summation z whole divided by its v equals to, and if I have done a mistake here, it's by n, I have left by n in this part, by n divided by n whole divided by n, it's whole divided by n. So now in this case I will simply split it, summation x y minus summation x summation y divided by n plus its delta, I will take delta common, summation x z minus summation x summation z divided by n whole divided by, so now let's give the value of v, it's summation x square minus summation x whole square divided by n, and now it's small xy plus its delta times small xz divided by its small x square, and if I summation x square plus delta times summation xz divided by summation square, so now it's beta hat, and its beta hat equals to, so now from here it's beta hat OLS plus something delta times summation xz divided by summation x square. So in case of omitted variable beta hat equals to beta hat OLS, which we required, plus delta times summation xz divided by summation x square. So now if covariance between x and z equals to 0, then summation xz divided by summation square equals to 0. So beta hat equals to beta hat OLS. Hence the omitted variable hence the omitted variable z is not a problem. This means that equation 1 also yields unbiased beta hat. But if COV x comma z is not equal to 0, then omitted variable z is a problem, and we must estimate coefficients from equation 2. We cannot use equation 1 because z and x are correlated with each other. But in case if z and x are not correlated, or it's 0, then it's safe to run the equation 1. Thank you.